Today's presentation is about the Pythagorean Theorem, but we're going to start with a little bit of review on quadratics because the Pythagorean Theorem is an application problem that involves a quadratic. So is this a quadratic relationship? I see my x squared, but it has an x to the third, so no, this is not a quadratic. This is a quadratic because the highest exponent is a 2. Let's solve this one like we did yesterday. Because this is the base of the exponent of 2, we can start by taking the square root of both sides. So now I have x minus 4 equals, don't forget both the positive and the negative answer. And then I can split that into two equations and solve from there. So I have to add 4. So x is 9 and negative 1. I'm hoping you're coming to this lesson with some background on the Pythagorean Theorem. Hopefully you remember that the Pythagorean Theorem is a squared plus b squared equals c squared, and it has to do with right triangles. Basically what the Pythagorean Theorem says is if you square one leg, so again the legs are the two sides that make the right angle. If you square them, so if you have a square coming off of them and add them together, it equals the square of the hypotenuse. The hypotenuse, remember, is the longest side, and it's the one across from the right angle. So, again, what the Pythagorean Theorem tells us is if we square one of the legs and add it to the square of the other leg, it equals the square of the hypotenuse. So I would definitely take a moment to write in your notes that the two sides that form the right angle are the legs. The one across from it is the hypotenuse. The square of leg 1 plus the square of leg 2 equals the square of the hypotenuse. And this allows us to find missing lengths. So to find a missing length, you have to decide if you are looking for the hypotenuse length or leg length. In this case, we're looking for the hypotenuse length. So we can just do a squared plus b squared equals c squared and fill in the numbers and square them. So 25 plus 49 equals c squared. And this is where solving quadratics comes in. So I add the a squared and the b squared, that equals c squared, and then we have to solve by finding the square root. So c is approximately 8.6. Now because, just like yesterday, this is an application problem, I am not going to take the positive and negative answer. I'm just going to have the positive because you can't have a negative length. So c is 8.6. approximately. And this makes sense because we know that it has to be the longest side. So we squared the first side, we squared the second side, we added them together, and then took the square root to find c. Alright, let's look at example 2. Again, you have to start by deciding if you're finding a leg or a hypotenuse. Here's my right angle. I'm given the hypotenuse, I'm missing a leg. So we have to treat this a little different. So think of it this way. If we squared the two legs and added them together, it would give us the square of the hypotenuse. So now we have to work backwards. We have to square the hypotenuse and then subtract the square of the leg to get the new leg. So instead of doing a squared plus b squared equals c squared, we're going to do the fact family c squared minus a squared equals b squared. So 13 squared minus 9 squared equals b squared. Take a moment, do the math, see if you come out with the same thing I do. Alright, I came up with b as being approximately 9.3. So I squared 13, I squared 9, and because I was finding a leg length, I had to subtract instead of add to get the square root of 88 equals the square root of b squared. So b is approximately 9.3. Alright, one last example. I see that I'm missing my hypotenuse, so I'm going to be adding. Remember, if you're finding the hypotenuse, you add. If you're finding a leg length, you subtract. So a squared plus b squared equals c squared. You can always, by the way, you can always use this even if you're finding a leg length, but again, in the end, you would be subtracting the a from the c squared, because when you're solving, you'll have these numbers. So if you want to just use this every single time you can, just make sure you're putting in the hypotenuse in for the hypotenuse for this type. Anyway, back to this problem. So I have now the square root of 5 squared plus the square root of 5 squared equals c squared. The square root of 5 squared is 5. So I have 5 plus 5 equals c squared. 10 equals c squared, and I'm going to take the square root of that to get, so I came up with c is approximately 3.2. So what you need to take away from this slide is when you're finding the legs you add, and when you're finding the, when you're given the legs you add, when you're finding a leg you subtract. All right, a couple different ways that we can apply the Pythagorean theorem. We can do a normal word problem, but we can also apply it to see if it is a right triangle. The Pythagorean theorem works only with right triangles. So if it does not work, then it means it's not a right triangle. This is called the converse of the Pythagorean theorem. So you just take the numbers, so a squared plus b squared equals c squared. And find your longest one. Remember, this is going to be c. The other two, it doesn't matter the order, but I'll just put them in order. 4 squared plus 5 squared equals 6 squared. 4 squared is 16. 5 squared is 25. What we're trying to figure out is, does it equal c squared? If it works, then it is a right triangle. In this case, 16 plus 25 does not equal 36. So no, this is not a right triangle. When it's a typical word problem, I highly suggest you draw out the picture. It says how far up a wall, so here's my wall, will an 11-meter ladder reach? So this is my ladder, and it's 11 meters, if the foot of the ladder must be 4 meters from the base. Now, clearly I didn't draw this to scale, but you still get the idea. So now here's my right angle. I'm given the hypotenuse. Since I'm given the hypotenuse, I'm going to subtract. Now pause it and see if you get the same thing I do. Pause, finish this problem, and see if you can complete it. All right, so I plugged my numbers in. 11 was my C. 4 was my A, and I solved for B. So I squared everything, I subtracted, and then I took the square root. And remember, it's only the positive. It's in meters, so I'm going to answer. It's approximately 10.2 meters. As I said, if you wanted to just use this Pythagorean theorem, a squared plus b squared equals c squared, and plug your numbers in, you can do that if you don't want to think about whether or not you're supposed to subtract or not. Sorry, this would be 11 squared plus b squared. So, because in the end, when you're solving this equation, you are still going to be subtracting. It's just a shortcut to write it as subtraction to begin with. And that's the Pythagorean theorem.